What if I told you that in the middle of one of the hottest places on Earth, ordinary villagers were making ice every single night? No machines, no electricity, no refrigeration. Just shallow holes in the ground and a handful of straw. And not just a little ice. We're talking about enough to fill the glasses of British officers, cool the fever of the sick, and supply entire households through the brutal Indian summer. This sounds like something out of a fantasy novel, but it happened. It was real, it was systematic, and the science behind it is so elegant that engineers today are basically trying to recreate it. So today we're going back to 19th century India, to the Thar Desert, where a group of villagers cracked open a loophole in thermodynamics and exploited it every single night. Stay with me because this story gets wild. Let's set the scene. Imagine you are a British colonial officer stationed in Rajasthan sometime in the mid-1800s. The temperature outside is somewhere around 110 degrees Fahrenheit. Your uniform is not breathable. There is dust everywhere. The sun is relentless in a way that feels almost personal, like it specifically dislikes you. You have come from England, where summer is a mild, occasionally pleasant inconvenience. This is not that. This is a landscape that punishes you for simply existing in it. You are sitting in your quarters, probably questioning your life choices, and then your attendant walks in and places a glass of water on the table in front of you. There is something floating in the glass. You look closer. It is ice. Actual, solid, frozen water. You pick up the glass and feel the cold against your palm, and for a moment you cannot process it. You are in one of the hottest deserts in Asia. Where did this come from? That question, where did the ice come from, is exactly what we are here to answer. The people responsible were a group known informally in historical accounts as ice runners, though the practice itself was carried out by entire village communities working in coordination. This was not the invention of one clever person. It was a collective technology, passed down through generations, refined over time, and executed with a level of discipline that would honestly put most modern workplaces to shame. The process began every evening as the sun went down, and understanding why it had to happen at night is key to understanding the whole thing. Here is the basic physics problem they were solving. You cannot freeze water if the surrounding air temperature is above 32 degrees Fahrenheit, which is 0 degrees Celsius. That is the freezing point of water under normal atmospheric pressure. This is not a suggestion. This is a law of nature. And yet the nights in the Thar Desert, even in winter, are not always below freezing. Sometimes the air temperature sits comfortably above that threshold. So how do you make ice in conditions where ice making should be physically impossible? This is the twist at the heart of this entire story, and it is the part that blew my mind when I first came across it. The answer is radiative cooling. And before your eyes glaze over, let me explain this in a way that actually makes sense. Everything around you right now is radiating heat as infrared energy. Your body does it, the ground does it, buildings do it. When the sun goes down, the ground starts releasing all the heat it absorbed during the day back into the atmosphere and eventually out into space. On a clear night with no clouds, this process happens extremely efficiently. The ground can actually become colder than the surrounding air temperature because it is radiating heat upward and outward into the cold darkness of space faster than the air can warm it back up. This is not a minor effect. Under the right conditions, a surface can be several degrees colder than the air just a few feet above it. Now here is where it gets clever. The villagers understood this phenomenon not through equations and not through physics textbooks, but through generations of careful observation and trial and error. They knew that on clear, dry nights, shallow containers of water placed close to the ground would lose heat faster than the air around them. They knew that desert nights, even when not technically below freezing by air temperature, could create surface conditions cold enough to freeze water. They had figured out, through practice, how to maximize this effect, and the setup they designed to do it is genuinely brilliant in its simplicity. The process started in the late afternoon as the sun began its descent. Villagers would dig shallow pits in the earth, usually only a few inches deep, spread across a large open field. The key word here is shallow. The pits were wide and flat, maximizing the surface area exposed to the sky while minimizing the depth, which would have trapped warmer ground heat. The bottom and sides of these pits were lined with straw, and this detail matters enormously. Straw is an excellent thermal insulator. By lining the pits with it, the villagers were cutting off the heat transfer from the warmer earth below and from the sides of the pit. The only surface left exposed was the top, facing the open sky. They were essentially creating little heat radiators, pointed directly upward at the cosmos. Into these lined pits, they poured thin layers of water, not deep pools, thin layers. Because the thinner the layer of water, the more quickly the surface temperature can drop. More surface area relative to volume means faster cooling. Every design choice here was optimized, not through engineering school, but through accumulated generational knowledge. By the time the water was poured, the villager's job was technically done. But here is where the discipline comes in. Here is the part that I find almost haunting. The fields had to be kept completely silent through the night. Not just quiet, silent. This is not an exaggeration in the historical accounts. The communities operating these ice fields enforced a strict code of stillness because any significant physical disturbance, people walking across the field, animals, loud sounds causing vibration, could agitate the water surface and introduce turbulence, which generates heat and disrupts the delicate cooling process. Sound also travels as a wave and creates physical compression in the air, which can very slightly warm it. More practically, people walking nearby would radiate body heat. Animals would radiate body heat. Any source of warmth moving through the field could raise the local temperature just enough to tip the balance. So imagine an entire village, organized and coordinated, moving around the edges of these fields in near total silence. The ice runners who would collect the ice in the morning operated in hushed movements. Children were kept away. Livestock was kept on the far end of the settlement. There is something almost ceremonial about this image. A community collectively holding its breath through the long desert night, protecting this fragile process, knowing that their discipline directly translated to the ice they could collect at dawn. By morning, a thin crust of ice would have formed on the surface of the water in the pits. The runners, often young men chosen for their speed and stamina, would begin collecting this ice before sunrise. This part of the timeline was absolutely critical. The moment the sun appeared on the horizon, the temperature would begin climbing. The window between enough ice having formed and that ice beginning to melt was very small. The runners had to move fast, harvesting the ice sheets, packing them into insulated containers, often more straw, sometimes clay pots, and transporting them quickly to where they were needed. The households of wealthy merchants, the residences of colonial officials, the compounds where doctors treated the sick. And here is a piece of the story that I think gets overlooked when people tell this tale from the perspective of the British colonists who were amazed by it. This ice was not just a luxury. Yes, it impressed the British officers. Yes, it was a status symbol for wealthy Indian households. But ice also had genuine medical importance in this era. Before modern medicine, bringing down a high fever was one of the most critical and difficult interventions a healer could perform. Prolonged high fever can cause brain damage and death. Ice was used to cool patients in fever crises. It was used to preserve food for the sick. It was used in surgeries to reduce bleeding and numb pain in a time before anesthesia was widely available. The ice makers of the Thar Desert were not just performing a party trick. They were operating what was, in effect, a medical supply chain. Now let us talk about the thermodynamic elegance of what they discovered, because modern scientists who have studied this ancient practice have been genuinely impressed by how precisely it exploits the physics. The principle at work is called radiative cooling, and it involves a specific atmospheric window. Water vapor and carbon dioxide in the atmosphere absorb and re-emit infrared radiation, which means they trap heat near the ground. But in certain wavelength ranges, the atmosphere is transparent. Radiation at those wavelengths escapes directly to space without being absorbed. This is the atmospheric window that makes radiative cooling possible. Objects on the ground that emit radiation primarily at these wavelengths lose heat faster than they can absorb it back from the atmosphere on a clear, dry night. The Thar Desert is one of the best places on Earth for this to work. The air is extremely dry. Low humidity means less water vapor in the atmosphere, which means a wider open window for heat to escape to space. The nights are clear. There are no clouds to act as a blanket, reflecting the infrared radiation back down to the ground. The combination of low humidity and clear skies creates nearly ideal conditions for ground-level radiative cooling. The villagers did not know the phrase atmospheric transmission window, but they knew which nights worked and which did not. They knew that humid nights or cloudy nights produced no ice. They knew that the driest, clearest nights produced the best results. They had mapped the relevant variables through observation, even if they lacked the vocabulary to describe them. The straw insulation underneath the water was protecting against conductive heat transfer, which was the enemy of the radiative cooling happening from the top surface. Conduction is how heat moves through contact. The warm earth below would have conducted heat upward into the water, counteracting the cooling happening at the surface. By insulating the bottom with straw, the villagers were essentially making the water communicate thermally with only one thing: the cold night sky above. The design was not random. It was optimized through centuries of iteration. What is interesting is that when the British first encountered this practice, many of them were genuinely baffled. There are written accounts from the 1800s of Europeans describing Indian ice making with a mixture of wonder and skepticism. Some initially suspected some kind of chemical process. Some thought the locals must be using underground springs or caves. The idea that you could make ice in a desert using only the sky as your cooling mechanism was counterintuitive enough that educated Europeans with scientific backgrounds took time to accept it. A physician named William Roxburgh, and later a more comprehensive documentation by British writer and naturalist Frederick Tudor, who was himself an ice trader, helped bring the process to wider Western scientific attention. Tudor was famously obsessed with ice commerce, and when he learned about what was happening in India, he recognized it as a competitor technology that Western science had simply not developed. The psychological dimension of this story is one that I keep coming back to. Think about what it takes to sustain this practice across generations. This is not something one clever person invents and others just replicate. It requires community trust. It requires people to accept the discipline of silence, not because anyone is forcing them at gunpoint, but because they understand that their collective behavior directly affects the quality of the outcome. The runners who collected ice in the pre-dawn darkness were not doing it for personal glory. The elders who managed the pit fields were not patenting their methods. The knowledge was communal property. The benefit, while often channeled toward wealthy households and colonial officials, also circulated through the community in ways historians are still piecing together. There is also something worth noting about the psychological experience of those British officers receiving ice in the desert. The shock of it was not just physical comfort. It was a confrontation with their assumptions. The Colonial project was built on an idea of European technological and intellectual superiority. And here was a community in the desert doing something European industry could not do without factories, ice houses, and supply chains stretching from frozen northern lakes. The Thar ice makers were exploiting physics more efficiently than any European operation of the time. For some officers, this created cognitive dissonance. They resolved by writing about it as a curiosity, an exotic local trick, rather than acknowledging it as what it was: a sophisticated applied science developed independently over centuries. Now here is the part of the story that carries a genuinely melancholy weight. The arrival of industrial refrigeration in the late 19th and early 20th centuries killed this practice within a few decades. Mechanical ice makers and refrigerators could produce ice in larger quantities more reliably and with less labor. The economic logic was clear. One by one, the pit fields were abandoned. The ice runners found other work. The straw-lined channels were left to fill with dust, and the knowledge that had been passed down through generations began to disappear. Not dramatically, not with anyone noticing it as a loss, but quietly, in the way that practical knowledge always fades when circumstances no longer demand it. By the mid-20th century, the practice had essentially vanished from living memory in most regions. It became a curiosity in historical texts, a footnote in accounts of colonial India. Something researchers would occasionally rediscover and write about with astonishment, as if they had found a lost technology rather than simply stopped paying attention to a living one. Radiative cooling is not just a historical curiosity. It is an active area of cutting-edge materials science and engineering research right now. In 2017, a team at Stanford published research on a material that could cool surfaces below ambient air temperature using the same basic principle that those their desert villagers exploited, radiating heat through the atmospheric window into space without any input of energy. The research made headlines. It was described as a potential breakthrough in passive cooling technology. Engineers are now working on radiative cooling paints, panels, and textiles that could reduce energy consumption in buildings dramatically. Cities in hot climates could theoretically reduce their cooling costs by coating rooftops with materials engineered for maximum radiative heat loss on clear nights. The ancient villagers of Rajasthan were, in a meaningful sense, the first engineers of this technology. They had no equations, no spectral analysis, no peer-reviewed journals. They had observation, iteration, community coordination, and a few centuries of cumulative refinement. And they produced a working system that scientists in the 21st century are working to replicate with billion-dollar research budgets. If that does not make you reconsider the relationship between traditional knowledge and modern science, I am not sure what will. There is a broader pattern here that I think is worth sitting with for a moment. History has a tendency to treat technological development as a linear progression from primitive to advanced, from simple to sophisticated, from ancient to modern. The Thar Desert ice makers break that narrative. Their technology was not primitive. It was precisely engineered to the available materials and the specific environmental conditions. It was sophisticated in the ways that mattered for its context. The fact that it did not involve machines or electricity does not make it less advanced. It makes it differently advanced, adapted to constraints that the industrial world solved by simply throwing more energy at the problem. The forgotten thermodynamics of evaporative cooling, which also played a secondary role in the process through the simple cooling effect of moisture evaporating from the soil and straw surfaces around the pits, represents another layer of physical understanding that the villagers had essentially mastered empirically. Evaporation requires energy, and that energy comes from the surrounding environment as heat, which means evaporation cools things down. Every time water evaporated from the straw lining or the soil around the pits, it was pulling a tiny amount of heat away from the water surface. This effect stacked on top of the radiative cooling happening overhead, and together they pushed the water temperature below the freezing threshold in conditions that, by air temperature alone, should not have permitted it. This is the part that genuinely makes my head spin when I think about it carefully. The villagers had figured out how to combine two separate cooling mechanisms, radiative heat loss to space and evaporative cooling from water phase transitions, in a single integrated system using only materials that were lying around in the desert. Straw, shallow pits, water, the open sky. That is it, the whole apparatus. And it worked well enough to supply ice to an entire region through the hottest months, night after night, year after year, for generations. I want to leave you with an image that I think captures something essential about this story. Picture the Thar Desert on a January night, maybe 2 in the morning. The sky completely clear and absolutely packed with stars. The air temperature is somewhere around 40 degrees Fahrenheit, not below freezing, not even close by the standard measure, but at ground level in those shallow straw-lined pits stretched across the open field, the water is beginning to crystallize at the surface. A thin glass-clear sheet of ice is growing outward from the edges, and around the field, in the darkness, villagers are sleeping in shifts, maintaining the silence, honoring the discipline of the practice. Nobody is speaking. Nobody is crossing the field. The whole community has organized itself around the fragile chemistry of ice formation. In a few hours, the runners will come, moving fast and quiet in the gray pre-dawn light, collecting what the sky and the science gave them overnight. It is one of the most human things I have ever learned about. A community that understood its environment deeply enough to coax something seemingly impossible out of it, night after night, with nothing but their knowledge and their collective discipline. And then, quietly, it was forgotten. Not because it stopped working, because the world changed around it and nobody thought to preserve it. The science they were practicing is now being rediscovered in university labs. The knowledge they held is being reconstructed from historical accounts. The thing they did every night as a matter of routine is now a topic of academic papers and engineering conferences. There is something bittersweet about that, but there is also something hopeful about it. Because if they figured it out with straw and shallow pits, imagine what we might do with it now that we actually understand the physics. That is the story of the ice makers of the Thar Desert. If you made it this far, genuinely thank you. This is the kind of history that does not make it into most textbooks, and I think that is exactly why it deserves to be told.